Alright, number 94. Number 94 is probably the hardest problem in the whole homework set. It says a speeding car is traveling at a constant speed when it passes a stopped police car. So here we have a speeding car. It's traveling at a constant speed and it passes a stopped police car. And this is traveling at 30 meters per second. And the police car accelerates. So every second that passes, the police car speeds up. So its initial velocity is 0. Its acceleration is 7. And that's it. That's all you really know. And it says, how fast will it be going? So it wants to know VF equals question mark. So that's what we don't know. And you might say to yourself, we don't know time and we don't know distance. And that's true. And same with the guy above him. You don't know the time and you don't know his distance. But the thing that's really great and unique is whatever distance it took the policeman to catch up, they're related somehow. This distance is equal to this distance because when they catch each other, they went the same distance, and same with the time. The times are the same. So our problem is going to be we have two unknowns. Actually, there's three unknowns in this one. We don't know the time and we don't know the distance. But the thing that's neat is these are related. The distances are the same. So just give them a variable. You can't just make something up. You can't just say, ooh, make it up, it's 10, because it's not 10. There's an actual distance to this. There's an actual time, and you have to get it right for this person that's increasing in speed to actually catch the one in front of it. There's a few ways to do this, but I'm going to do it with, I have two unknowns. I'm actually, believe it or not, I'm not going to worry about this for right now. I'll come back to it. I've got two unknowns. So I'm going to take all this stuff over here and I'm going to use velocity is equal to distance over time. My velocity is equal to 30.0. The distance is d and the time is t. So there's one equation. Now I'm going to generate another equation with this. It's the one that doesn't involve final velocity. And it's d equals vi t plus 1/2 at squared. And you're wondering, where in the heck am I going with this? Well, if I have two unknowns, I have to get two equations to solve for my two unknowns. So then I have this one. The distance is d. The initial velocity is 0, so this cancels out. 1/2. The acceleration is 7 t squared. Now, if you look at this, I've got two equations with two unknowns in it. So you can solve this all different ways. You can use a matrix. If you wanted to solve it with a matrix, you could solve it by graphing, where did they cross, or you could solve by substitution or elimination. I'll probably do a substitution, that's probably the easiest. 30.0 t is equal to d, and then I'm going to take this and plug it in there. So 30t is equal to 1/2 7.0 t squared. Right? So then I solve it. So that's 3.5 t squared is equal to 30t. I'm losing my significant figures just because I really don't really worry about them right now. So 0 equals 3.5 t squared minus 30t. Now you can solve this for t because you could do it a couple ways. You could use the quadratic, or you could factor. I'm going to factor it out. So I'm going to factor out a t. So t is equal to 3.5t minus 30. And that equals 0. So the question is, well, solve this for t. Well, t equals 0, and also t equals, where does this piece equal 0? Where does 3.5t minus 30 equal 0? Well, you move the 30 over, so 3.5 equals 30t. So t is equal to 30 over 3.5. 30, 3.5. And that's 8.57. And that tells you something. That tells you the cars are together at time equal 0. Does that make sense? Heck yeah, it does. At the very beginning, that's where he passed him, and he was standing still. And they also catch each other at 8.57 seconds. So over here, the time is 8.57 seconds, and you're saying to yourself, why did I even care about the time? I didn't want it. But you know what? Now it works. Now you've got 4 things. So we're going to use the one that doesn't involve distance to actually kill this problem. So you're going to use, let's see here, VF equals VI plus AT. That's going to kill this problem because the final velocity, that's what we're looking for. The initial velocity, it's 0. The acceleration is 7. And the time, it took 8.57 seconds. So you take 7 times 8.57, and you get 60. It's like 60, right on the money. I didn't use 8.57. I used the whole thing in my calculator, 8.57143. So the answer is 60 seconds. So, but you got to do it with 2 significant figures, because everything it gave you is with 2 significant figures. So you got to write 6.0 times 10 to the 1. Oh, no, that's velocity, so that should be meters per second. And there it is. This is a really tricky problem because they don't give you much, but the things they do give you are related. You don't know the time and distance, but the time and distance are the exact same for both of them. So you generate 2 equations with 2 unknowns. I did right here. My first equation, my second equation, set them equal to each other, and I got the time. So I had to take 1 step backwards to take 1 step forward to actually get my answer, because I had to find time in order to get the final velocity.